Hello everyone, today we're going to solve the LeetCode daily problem number 1123, lowest common ancestor of deepest leaves. In this problem, we are given the root of a binary tree and we need to return the lowest common ancestor of its deepest leaves. So let's clarify a few definitions first. A leaf is a node that has no children. The depth of the root is 0. If node has depth d, then its children has depth d plus 1. The lowest common ancestor of that of node is the deepest node, such that all nodes are in subtree. So let's move to first example. Here we have a basic binary tree and we have the solution. In this example, the solution will be 2 as the lowest leaves are 7 and 4, while we have other nodes that don't have leaves, that don't have anything connected to them, like 0, 8, and 6. They are higher in hierarchy. For example, if we count from 0, we have 1, we have 2, we have 3. So they are related on the level 2, then 5 and 1 related on the level 1 and 3 on level 0. So our task is to find the lowest node that has no children and has common ancestors. So for example, as here 2, it has 2 children, 2 nodes, and it's common ancestor for them, so the parent. For this problem, we can use deep first search, DFS, in bottom-up manner. So instead of looking from the top, we will start looking from the bottom up to top to search for common ancestor for them. So for example, as here we have ancestor 2, but just imagine a case scenario when we remove 4, for example, then we have another candidates for our ancestor. Or for example, we can remove 7 and 4, and if we remove them, then we have 2 candidates. We have 5 and 1 as ancestors, but again, we need to return the lowest, so we will go up, and we have 3 as ancestor of 5 and 1. So in this case, we approach the maximum depth of its subtree, and we will use the candidate node. So we will use, for example, the candidate 7, and we check its depth, then candidate 4, and so forth. In base scenario, we will return 0 and no candidate if, for example, the root is empty. For example, like in scenario where we don't have anything there. So mainly recursive logic. So let's start with algorithm. Algorithm will be depth first search. Then we will define a DFS function with parameter node. Then we will have the basic check. So if node, we return 0 and none. After this, we will need to check the deepest of the root. For that, we will use recursive call. So we will start from left side, left depth, and left lowest common ancestor, LCA, will be equal to DFS of node left. The same goes logic for the right side. So we have right depth, and we have right lowest common ancestor, which will be equal to DFS node on the right side. After that, we'll need to make check of 3 parameters. If the node, the lowest common ancestor on the left side, or if it's on the right side, or they equal, and we should return in the middle. So for that we will use if logic. So if left depth bigger than right depth, this means that we return the left side. So we will return left depth plus 1 and left common ancestor. In our if scenario, left depth will be smaller than right depth, and we do almost the same, just changing left to the right side. So we will return right depth plus 1 and right always common ancestor. And else, if it's not bigger, not smaller, it will be equal, so we can just return left or right, it doesn't matter, depth plus on and not itself. Lastly, we need return statement for DFS, put root inside and one position. So let's run our code. Oh, typo. I think it's just typo right there. Yeah, unacceptable. And let's submit. And runtime, it's 100. So for this code, time complexity will be of big O of n, as in the worst case scenario we'll need to search for all nodes, and space complexity also will be of O of n. So thank you for your attention and have a nice day. Bye.